Here, the reading of spring balance is nothing but restoring force. Reading of spring balance is restoring force. Here, what are the forces acting on this? Its own weight, the restoring force developed in the spring. So one system moves downwards with an acceleration A, applying Newton's laws on this block, mg minus kx here is ma. This is 1 inch. Here at this point, restoring force, like tension acts away from the point. Here it is mg. Here it is a string, not a spring. So since it is moving downwards, mg plus kx minus t is equal to ma. And here it is mg t minus mg is equal to, adding all this, mg get cancelled, kx get cancelled, mg here is, so acceleration is g by 3. So then, considering first equation, kx will be m times g minus c, g minus g by 3, which is 2mg by 3. Here is circuit having resistance 30 ohms in series with an inductance is connected to an AC supply, and peak voltage is given 220 volts, and what he is asking is power consumed. Power consumed is Vrms IRMS into cos phi. So that is power is equal to peak voltage by root 2, I naught by root 2, cos phi is R by Z. Here, what is the maximum current? 1 ampere. V naught is 220 volts. So 220 by root 2, 1 by root 2. Resistance is 40, R is 30 ohms, where Z is root of R square plus XL square. We given XL as inductance as 40 ohms, which is 50. So here 110 into 3 by 5, that is 66 watt. Here a rectification has 3 identical resistors, each of resistance 18 ohms. If all of them are connected in series, so the resistance, effective resistance is 54 ohms. They are connected in parallel, then 1 by R is 1 by 18 plus 1 by 18 plus 1 by 18. R here is 6 ohms. By the combination of 2 or more taken using you are using a single resistor, the resistance cannot obtain. So we can get 54 ohms, we can get 6 ohms. If 3 resistors are connected like this, 18, 18, 18, they're parallel, the effective is 9 ohms plus 18. We can get to 27 ohms. He said he cannot. So this is possible. It can't be the answer. If you take only uh, two resistors, 18, 18. So we get 9 ohms. We take 18, 18 in series. We get 36 ohms. So this cannot be the answer. So now answer can be either 12 ohms or 15 ohms. Here, what is the other possibility? Either single resistor means all are 18 ohms. So two resistors possibility series and parallel. Okay. Three resistors. If we connect 18 ohms in series, here it is 36 into 18 by 54. So here it is 12 ohms. So this cannot be the answer. So we cannot obtain 15 ohms. We can get different type of effective resistance if we combine them in different ways. Here, equiconvex lens. Equiconvex lens means R1 equal to R2. 1 by F is mu minus 1, 1 by R1 minus R2. Where R1 is positive, R2 is negative, plus 1 by R. Effective, this is 1 by F, focal length of a lens. But they cut along the diagonal, there is no change in the radius of curvature. Once there is no change in the radius of curvature, after cutting also, its focal length of its focal length. So focal length of combination 1 by F effective will be 1 by F plus 1 by F, which is 2 by F. So effective will be F by 2. Here, a particle starting from mean position is in SHM with a time period T, then time taken by the particle to complete 3 by, this is for one complete oscillation. Started at mean position, again reaching mean position, that is one complete oscillation. This is 1/4 oscillation. So we know that time taken to complete 1/4 oscillation is T by 4. Now, 3 by 8 oscillation means, so that is remaining part 3 by 8 minus 1 by 4 or 3 by 8 minus 1 by 4. That is 3 minus 2, 1 by 8 oscillation still left over. So 1 by 8 means again, so in the return journey, it will complete half of the 1/4 of oscillation, that is 1 by 8. So here time taken will be from mean to, this is mean position, that is extreme position. So time taken from mean to middle is x is a sine omega t. So sine omega t will be half, which is sine pi by 6, 2 pi by t of t. T will be t by 12. So from here to here, it is t by 4 minus t by 12. 2t by 12, that is t by 6 seconds. Now from here to here, it is t by 4. From here to here, it is t by 6. So here it is 5t by 12, which is given it as kt by 24. K value is here an electric at 100 watt, 40 watt has to be operated across 50 volts. What is the value of inductance in series with the bulb? Here it is bulb which has some resistance. It has to be operated. What is the value of inductance which is connected in series to AC supply? Here across 50 volts and operated at 50 Hz frequency. The resistance of a bulb is calculated by using a formula. V square is 40 into 40 by power is 100, that is 16 ohms. So what we don't know is, we don't know what is inductance, which we have to find out. Here, is it possible to find potential difference across resistors? He told it is rated at this. So maximum current drawn by a bulb when it is P here is VI. I will be 100 by 40, 2.5 amperes. So potential difference across resistor 2.5 into resistance 16. So 16, 32 plus 8, 30 ohms. Since they are connected in series, V square is VL square plus potential difference. So 50 square is VL square plus 30 square. VL will be 2500 minus 1600, that is 40 volts. So now VL is nothing but IXL is equal to 40. XL is 40 by I 2.5, that is 40 into 2 by 5. So here XL is 60. Omega L is 60. L here is 16 by 2 pi F. 2 pi F here is frequency 50 Hz. 60, 40 ohms. 40 means real will be 30. 30, here 30. So 12. So XL here is 12. Omega L is 12. Here 2 pi frequency is 50. L is equal to this. 100 pi L is 12. So L here is 12 by 100 pi, which is K by pi. K is 12 by 100. 100K will be 12. So your tuning 4K produces. So let N1 be frequency of tuning 4. A. Let N2 be frequency of tuning 4 B. So number of beats is equal to N2 minus N1, which is equal to 3. So if frequency of tuning fork is 343, then frequency of tuning fork B will be either 340 or 346 Hz. Now, when B is loaded, its frequency decreases. That means value of N2 will be smaller. But he says after loading also frequency is unchanged. Frequency is unchanged. That means N2 dash now after loading its frequency N2 dash frequency of tuning fork is this, remaining bit frequency remains unchanged. Here N1 is 343. So N2 dash, if you take after loading, B frequency decreases. So B frequency, if you take 340 as frequency of B, further reduces, let us say some 338. 338 minus 345 will be bit frequency cannot be 3. So if you consider 346 as frequency of a tuning fork B, after waxing, its frequency decreases, so that uh, difference can be bit frequency can be 3. So I can say here, which implies N2 dash will be 346 H. Here, the pressure of an ideal gas is P cube V is equal to constant. Taking log 3 log P plus log V is log K. Differentiating, we get delta V by V is equal to 0. So bulk modulus will be K, which is minus delta P by delta V by V. From here, delta P by P is minus delta V by V. From this relation, we get it as P by 3. So the value of constant is 3. Here, so among these two cells, so dominating EMF is 6. So let us assume that current flowing in this direction. Let us find potential difference by taking as clockwise VA here minus 6. Since current is flowing in opposite to the direction of the path, we will take plus I, which is equal to B. So VA minus VB is 6 minus I, 7. So here, if you consider path like this, VA to VB, VA minus 3 volts, positive to negative. So here we are choosing path in the direction of flow of current. So there is a loss of voltage which is equal to B. So that is VA minus VB is equal to 3 plus 2I. Second, 6 minus I will be 3 plus 2I. 3I will be 3. I here is 1 ampere. VA minus VB will be 6 minus 1, which is 5 volts. Here, a ball of mass 4 kg strikes another stationary ball of mass 2 kg with a velocity. Assuming collision is elastic, momentum and energy both are conserved. That is M1U1 plus M2U2 is M1V1 plus M2V2 half M1U1 square plus, which is half M1V1 square plus half M2V2 square. From these two relations, further simplification gives final velocity. It is a standard formula M1 plus M2 of U1 plus 2M2 by M1 plus M2 of U2. Here he is asking 4 kg. Here M1 is 4 kg, which is moving with 10 meter per second. M2 is 2 kg, which is at rest. So V1 will be M1 minus M2 by into U1 plus 0. Answer is 10 by 3 meter per second, which is K by 3 means value of K is 10. Here, during polytropic process, pressure is found to be inversely proportional to cube of volume. So that means PV cube is constant, PV power gamma is constant. Here gamma is 3. So Cp by Cv is nothing but gamma. Here position of X of a body changes. Position time graph is same as displacement time graph. So here what it says, graph initially at rest, in 2 seconds it traveled 5 meters. Again it traveled here, what it says, it is somewhere 4.5, again 4.34, right? Again further in another 4 to 10 seconds it traveled from 3 meter to, let's say this is 3 meters. Again what distance? 7 meters further. So but here he is asking speed. Speed means we have to consider distance. First it traveled here, body changes its position by 5 meters and then it moved 2 meter in this direction. Further 3 to 7 meters means 4 meters. Totally 11 meters distance is covered within a span of 10 seconds. So average speed will be 11 by 10, which is 1.1 meter. Here it is. The standard question, this one. Here first you should have an idea of condensation. Condensation means process which water vapor changes into liquid water. So here it is, 1 gram of steam at 100 degrees centigrade. So by losing 540 calories of heat, it converts to 1 gram of water at 100 degrees centigrade. So here it is, to convert 1 gram of water at 100 degrees centigrade to 1 gram of water to 0 degrees centigrade. Once condensation happens, it loses heat by releasing a heat ms delta T, that is 1 gram into specific heat 100, which is 100 calories. That means totally 640 calories are released in this process. So to melt 1 gram of ice, 80 calories are required. So with 640 calories, so 8 grams of ice can be melted. Here it is. Incident energy is hc by lambda, or that is here he given frequency. Frequency is c by lambda, that is 3 into 10 power 8 by 3 into 10 power 14, which is 10 power minus 6. So now hc value is 1240 electron volt nanometers. hc by lambda is 1240 electron volts nanometer by lambda value is 10 power minus 6. So which is 1240 into 10 power minus 3 electron volts, which is 1.24 electron volts. So which is less than work function 4 electron volts. So photoelectron is not released. So which implies velocity of photoelectron is 0.